All right, let's dive right into this explainer and begin our descent into what is absolutely the most fascinating and hidden ecosystem on Earth, the deep ocean. Today, we're looking at the massive 2024 deep sea discoveries. We're exploring those abyssal frontiers and the unprecedented data hauls that are, quite literally, rewriting our understanding of the world right below the surface. But before we map out our mission, I want you to ask yourself a question. Just how much of our own planet remains entirely unseen? I mean, it's incredibly easy to look up at the stars and think of space as the ultimate final frontier, right? But right here on Earth, there is this vast, pitch-black wilderness that remains a massive blank spot on our global map. We're talking about regions thousands of meters below the waves. The pressure is immense, the temperature hovers right near freezing, and the darkness is absolute. Yet, as we're going to see, it is teeming with complex structures and bizarre life.
So here is our itinerary for today. We'll be charting the 2024 NOAA expeditions, looking at Embry's deep-sea revelations, uncovering Pacific abyssal wonders with the Natural History Museum, unveiling hidden seamounts with the Schmidt Ocean Institute, and then wrapping up with why the deep actually matters to us.
Section 1, Charting 2024, NOAA Expeditions. Our descent starts right at the surface with the National Oceanic and Atmospheric Administration, NOAA, and their really broad 2024 ocean charting efforts. You know, the sheer scale of NOAA's continuous ocean exploration timeline throughout 2024 is just a masterclass in coordinated logistical science. Starting in Q1 with the launch of their exploration operations, they faced this immediate hurdle of calibrating advanced multi-beam sonar arrays so they could penetrate thousands of meters of water column. Then, moving into massive deepwater mapping expansions by Q2, they started filling in these high-resolution bathymetric gaps of the Pacific seafloor. By Q3, they were actually getting eyes on the seafloor, deploying advanced dual-body remotely operated vehicles. These things are capable of withstanding crushing pressures, all while capturing 4K video of entirely unmapped terrain. And by the time we hit Q4, the focus shifted to intensive data analysis of these previously uncharted depths. It's been a rigorous, year-long campaign utilizing cutting-edge telepresence technology to essentially pull the deep ocean out of the dark and onto our maps in real time. Moving to Section 2, Embry, Deep Sea Revelations. As we travel a bit deeper, our next stop brings us to Embry's targeted biological revelations down in the abyssal frontiers. Now, 2024 isn't just another year of research. It's really become a landmark inflection point for identifying entirely new forms of deep-sea life. This is the exact moment where our technological capabilities, think advanced environmental DNA sequencing and precision robotic sampling, have perfectly aligned with our scientific curiosity to unlock regions we used to think were completely barren. Embry's singular focus on unlocking the weird, wonderful biology of the deep ocean has yielded absolutely unprecedented results this year. We're talking about the identification of entirely new species. For example, they found these remarkably delicate benthic ctenophores and deep-sea crown jellies that are so fragile, they would literally disintegrate if brought to the surface. But by utilizing major advancements in deep-sea biological tracking, scientists can observe these organisms right there in their natural, undisturbed habitats. They are making discoveries in completely uncharted abyssal frontiers, revealing incredibly unique ocean floor ecosystems. And this isn't just about cataloging a single new fish or piece of coral, it's about understanding complex, fragile food webs that rely on chemosynthesis and marine snow in environments we previously considered to be biological deserts.
Let's move on to Section 3, NHM Pacific Abyssal Wonders. Let's see how this biological catalog expands even further as we enter the crushing depths of the Pacific with the Natural History Museum.
The Natural History Museum has been pulling the curtain back on abyssal wonders that completely challenge our understanding of biological resilience. Specifically, their recent surveys in deep-sea plains, like the Clarion-Clipperton Zone, have revealed extraordinary new deep-sea species hidden within the Pacific abyss. These are organisms demonstrating radical evolutionary traits. We're talking abyssal gigantism and unique metabolic pathways that allow them to survive in a nutrient-starved environment. It completely defies the standard rules of biology we've established up at the surface. With a strict focus on the Pacific Ocean deep sea, they are uncovering previously unknown species left and right. From uniquely armored crustaceans to totally novel forms of sea cucumbers that act as the primary bioturbidators of the abyssal plain. This is drastically expanding our entire catalog of abyssal biology. But honestly, the most fascinating part is that they are showcasing life in extreme pressure environments. We're talking about operating at depths exceeding 4,000 meters, where the hydrostatic pressure surpasses 6,000 pounds per square inch. Discovering soft-bodied organisms thriving under the equivalent weight of a commercial jetliner on every single square inch of their bodies, that completely shifts our paradigm of where life can flourish. Let's dive into Section 4, Schmidt, Unveiling Hidden Seamounts. Our final destination brings us to the geological marvels mapped out by the Schmidt Ocean Institute. Before we get into Schmidt's recent discoveries, we kind of need to understand the complex bathymetry we're talking about. So, what is a seamount? Simply put, it's a large underwater mountain, usually formed by volcanic activity that rises from the ocean floor but doesn't quite reach the surface. But to oceanographers, these are way more than just rocks. These steep slopes interrupt deep ocean currents, which forces nutrient-rich upwellings that transform these isolated peaks into massive, pelagic biodiversity hotspots. They act as vital waypoints for migratory marine life. To put that into perspective, when we compare these hidden ocean seamounts to famous terrestrial mountains, the scale is just staggering. Some of these underwater structures tower over 3,000 meters from the abyssal plain. They rival or even surpass iconic peaks like Mount Fuji. Yet, because their summits remain hundreds or thousands of meters below the sea surface, they exist entirely hidden in the silent, dark waters below. They've just completely escaped detection until right now. The Schmidt Ocean Institute's recent discoveries have unveiled these towering, previously hidden seamounts, specifically along highly active tectonic regions like the Nazca Ridge off the coast of South America. Now, you might be wondering, how did such massive structures hide for so long? Well, previous satellite altimetry could really only give us a blurry estimation of the ocean floor, totally missing these sharp vertical features. But by using high-resolution shipborne multi-beam sonar, Schmidt is practically redrawing the map of planet Earth. They're filling in giant global blank spots, mapping spectacular underwater mountain ranges that completely change our topical understanding of the ocean floor. Which leads us to our final section, why the deep matters. Okay, let's pull the whole shebang together and ask, why do these 2024 expeditions and discoveries actually matter to you? It's because every step of this expedition connects the physical structure of the ocean to the breathtaking biology it supports. It starts with Step 1, broad ocean charting by NOAA mapping the unknown. That foundational topographical work leads right into Step 2, highly targeted geological mapping by the Schmidt Ocean Institute, revealing those hidden physical habitats and current-altering structures like the seamounts we just talked about. And finally, Step 3, institutions like MBARI and the Natural History Museum deploy their submersibles to those exact coordinates to discover the new species actively thriving in those abyssal frontiers. It is a perfect, interconnected synthesis of geology, mapping, and biology that reveals one cohesive living ocean. The abyssal frontiers and hidden seamounts of the deep ocean remain our planet's greatest untold story. You know, that quote really hits the nail on the head. It brings us to a profound realization about the vastness of the undiscovered world sitting right beneath the waves. The more advanced our hydroacoustics and robotics sampling become, the more we realize just how massive the gaps in our fundamental understanding of our own home truly are. I'll leave you with this final thought to ponder as we conclude our explainer today. How much of our own planet will we leave undiscovered? As technology advances and 2024 pushes the boundaries of deep-sea exploration, the answer is shrinking every single day. But there is still so much more to map, to catalog, and to understand. So keep exploring, keep asking questions, and I'll see you in the next explainer.